If you've been able to follow along with the series so far, you should be getting pretty good at creating parts inside SolidWorks. We've taken a look at a lot of different examples from very simple parts to molded parts, complex parts, welded sheet metal parts, you name it, but they all had one thing in common, and that's the fact that they were parts. Now, in a part environment, you can have a single body, you can have multiple bodies, you can have surfaces and solids, any number of combinations that you can work with. And there are some little tricks where you can actually get things to move around inside of the part environment. But there are three distinct different types of files inside SOLIDWORKS: the part, the assembly, and the drawing. Now we'll talk about drawings later, but in this series or this section, we're going to start talking about assemblies. And I really want to focus on how to create assemblies and talk about some of the downfalls and what assemblies are and what they mean. When you start a new SOLIDWORKS document, you can create an assembly directly from in here. You simply choose your template, and if you want to make any custom changes to your template, just like we did with the original part templates, you can do that and save them as an assembly template. Let's go ahead and say assembly millimeter and start and just see what we get here. Now it looks very similar to the part environment, but there's a few distinct differences that we need to know. On the left-hand side, when you start to create an assembly, it's going to ask you for two things: either to create a layout or to start inserting parts. Now there are some options down here as well as like thumbnail preview of whatever component you're selecting, and some general options such as start command when creating new assembly, which is really this pops it up when you start a new assembly. If you deselect this, you won't get this dialog box to pop up every time. Also show things like rotate context toolbar and so on. And really, this is the basic start to an assembly. There are several other ways that we can do it. But what I really want to focus on is what an assembly is. Now, an assembly is essentially an empty file. That's not universally true, but essentially it's an empty file that is looking for components. It's looking for references. So if you think about creating a hyperlink to a website, you don't have that website in your hyperlink. You're really just redirecting the user when they click on it to go to a certain website. And an assembly is a very similar sort of aspect. It doesn't contain the part itself, it contains a link to the part. And it gives us a few advantages. Assemblies can be lightweight, which means you don't have to fully load components. If you have very complicated parts, if you have lots of surfaces or thousands of features, you don't want to reload that every time you make a change or you move or connect things or move them around or just check the motion on them. Well, in an assembly, you can load it as a lightweight component, or you can go into a large assembly mode where you're really just loading a graphical preview of it, a very simplified outside shell. It still looks identical, but you don't have to load all the features and all that information. It's just simply redirecting to what that thing looks like. Very handy because you no longer have to suffer the performance strain of having these complicated parts located in your assembly. But with that said, it's very important that you understand that you're referencing the location to a part. That means if you move the part in your Windows Explorer, on your desktop, wherever it is, if you move it, you're going to need to reconnect those references. Once we start to create an assembly, I'll start talking about references and where they're looking and so on. But it's very important that you understand that from the get-go, because you can't just bring parts into an assembly and assume that they're always there. Because if you don't send them in, especially if it's like a toolbox component or some other downloaded component that's in a different directory, they might move, they might get lost, and it might really mess up your assembly. So it's just a little bit of a word of caution when you go into assemblies. Just note that you're bringing a reference to the assembly. You're not actually bringing the components in. And of course, you can copy them, you can pattern them, you can do all kinds of things to them inside the assembly environment, but they're not really there. So just keep that in mind. Now, assemblies have several of their own benefits that take you a little bit outside of what a part can do. You have some great exploded view options. So if you're making detailed drawings and you need to basically separate components of your design, whether it's screws holding a component on, whether it's bearings, clips, seals, whatever the case is, to make your very nice detailed drawings, typically you're going to come and do an assembly. You can do exploded view drawings in SOLIDWORKS part files now, but it's really made for the assembly environment. There's also great things that come along inside the assembly environment, like bill of materials. Now, when we did our example on creating weldments, sheet metal weldments, and creating those types of files, you have what's called a detailed cut list. And you have multiple solid bodies in those part files, and you will get a table in a drawing, which again, we'll handle later. We'll talk about that later. But when you have assemblies, you get bill of materials. That means a detailed list of all the components, multiple components, any custom properties you want to send along with that. A very nice functionality inside the assembly environment. You also have some great things to do inside the assembly environment, like create patterns of components or mirror components, create left and right hand versions of components without having to completely model them. So very handy functionality to save you the time to only have to draw one component and then pattern it inside here in the assembly. You also have things like move and rotate functionality, which is a little bit different in the assembly environment. When we add mates to our components, which is going to be a reference or a link between edges, faces, vertices, bodies, things like that, on how they move together, you'll see that we have a lot of functionality on how components move. And inside the move component option, which we don't have any solid bodies in here, but inside of here, when you move solid bodies around, you have collision detection and physical dynamics. These are options that allow you to physically push other components with solid components. So if you have a solid block and you have a second solid block using physical dynamics, you can push it around a tabletop or around a plane. So very handy functionality to see how components really interact inside of the 3D model space. Now, of course, all these things drain the performance of your computer. So if you're really maxed out at running SolidWorks alone, it's going to take forever for you to use things like physical dynamics or really complicated mates. But these tools are here and they are available to you. In our examples moving forward, we're going to look at some of the basics. We're not going to create a very complicated assembly, but we're going to look at the basics of how to create your assemblies through various means, whether it's inserting components, whether it's making components here, starting our layout sketches, and so on. So hopefully you have enough information to go on and really take your assemblies out to the next level.